Hello, welcome to this presentation about Python in Fabric for data engineers. Being fluent in T-SQL isn't good enough anymore. Whether you want to analyze some data using NumPy and Pandas using Jupyter Notebooks, or you want to create a lakehouse in Microsoft Fabric using the Delta format, or you want to connect to Excel sheets living in SharePoint, or connect to REST APIs, Python is a good language to do all these things. The goal for this presentation is to get you up to speed with Python, learn you about the syntax and all these different technologies that everybody's talking about. But first, let's introduce myself. My name is Arthur Graus. I'm a Power BI and Microsoft Fabric trainer, developer, and last year I also started working with machine learning. That's also why I started learning Python, because in the machine learning world, that's the language to use. I gave a lot of trainings about Power BI mostly, but also Fabric. I used to do a lot of SQL Server BI trainings in the past. If you have some questions about Python, Power BI, Fabric, feel free to send me an email or connect to me via LinkedIn. Maybe for a lot of us, Python is relatively new, but it's not a new language, not at all. It's like 30 years old. It's invented by a Dutch guy from Rossum. And we're not going to look at all the iterations. We're on iteration 3 of Python. But if you look at the popularity, then it's grown steadily. And now it's the #1 programming languages being used for all kind of different purposes. So that's a good language to know, right? How to get started. First, what you need is get an installation. You can just install just Python, or you can get a distribution like Anaconda, especially if you also want to do some machine learning or data science kind of things. Then this is a really good distribution. And you need an editor, an IDE, integrated development environment, in which you can type in the code and debug your code. Of course, you can use in Fabric the notebooks, but if you really want to have a lot of code and debug it correctly, then Visual Studio Code is, in my opinion, better. It's a lightweight tool, it's free to download, and it has some extensions for Python and Jupyter Notebooks, and even some extensions to work with Fabric and to debug the code from Fabric. Let's take a look at some syntax and expressions for Python. How can you declare a variable? You don't need the word declare like in T-SQL. You can just assign a variable like first name equals John or last name equals Doe. And if you want to have like a string, you can use double quotes or single quotes. If you want to concatenate strings, you can just use the plus, basically the same like in T-SQL. All these variables are also objects. So in this case, this is a string object, and it also has methods like .upper, you get the uppercase, .lower, lowercase. A string is also like an array, so you can use an index to get a specific character. Like if you want the first character, you use a 0, it's always 0 based. This syntax is a little bit more tricky. It means it starts with index 1, so the second character, and then till the third character. So basically character with index 1 and 2, in this case O and H. If you want to know how many characters are in a string, you can use the length function. If you want to have a single quote inside the string, and you're already using single quotes to start and end the string, you need something else. You can escape it by backslash. But what if you need a backslash inside the string? Then you have two options basically. You can use a double backslash to escape it, or you can use something that's called raw strings. So you can do like a prefix with an R, and then you can just use the backslash. But you cannot do this trick anymore. You cannot do backslash a quote, for example. That doesn't work. Another neat trick in Python is what if you want to have like a big string and you want to embed in this string variables that you have. Like I want in this case to create a username, extreme, backslash, and then the first name of the user. Then you can use here the curly brackets, and in the curly brackets you can have like a variable name if you add the F. That's what I call a format string. Let's see how this looks like in real code. For that I'm going to switch over to Visual Studio Code. This one. Here I opened up the same Python code. Python is always inside a Py file, a Python file in this case. And if I want to test out the code, I can click Run. and then it's going to print the output. In this case, for example, the raw string is going to print the output here in the terminal window. So here I can try it out. Here I print a format string extreme. What if I want to add, for example, the last name? Then here I can add curly brackets, and then here I can take another variable last name. You see you get IntelliSense. You can just click on it, dot, and then you see all the methods that you can use when having a string variable, like upper or lower. And then I can run it again, and I can see the output extreme John Doe in this case. Do you want to add a dot? Then in between here I can add some literal text like a dot, and then run it again, and you can see here a dot is added. What if you want to have like a multi-line, like have enters inside? You can use this syntax, the \n. What you can also do is have 3 double quotes. So if you start a string with 3 double quotes and you close it with 3 double quotes, a difficult word, then you have a multi-line string and you can add extra lines here. Very handy if you want to have like some T-SQL code that's spread out across multiple lines. Okay, let's move on to numeric expressions. I'm not gonna go over that too much. There's a module called math where you have all kind of mathematical functions like floor, ceiling, sinus, cosinus, tangens, these kind of things. For the rest, it's just normal things: adding, subtracting, multiply, division. Let's look at the formatting. I think that's more interesting. If you want to parse a string, for example, you type in a string or you get a string from a REST API, for example, and you want to parse it into a decimal, then you can use this one, locale.a2f, meaning as ASCII to float. Of course, now it's not ASCII anymore. It used to be ASCII, but now it's UTF, Unicode string, but it still has the same name, ASCII to float. And then you can specify like a variable. With the input function, you can ask somebody to type something in. So I can type in a value, like in this case. This is formatted the Dutch way. So we use a comma as a decimal separator and a dot for the thousand separator. And here I can specify the locale to be a Dutch in the Netherlands. And then it's going to parse it correctly, and the var decimal will be a correct decimal. And then you can format it using the format string again. With the curly brackets, you have a variable and then the colon, and then, for example, .2 means 2 decimals, like this, or .0 means 0 decimals, or if you add a comma, you get like a thousand separator. And maybe you want to have like extra zeros in front of it. You can use this syntax to fill it up. Now we have a 09. If you want to work with dates, that's also something that you come across quite a lot. What if you want to see what the date time is now? We have a date time class .now, and we have a date class .now, and they're all in the date time module. What you see here, basically you say from this module, I want to import the date time, and the time delta, and then you can use it in your code. From a date object, you can also get a property year and a property month. And yeah, with that you can do some calculations. And the nice thing is, if you have 2 dates, for example, I have today and I have, for example, birth date, if you subtract them, then you get a time delta object. And from the time delta object, you can get like a property.days. Let me show you here in Python. If I take this one, so here I have them subtracted. And if you do the dot, then you can see which kind of things you can get from it. For example, .days. Let's take a look at some logical expressions. So how do you do an if? In T-SQL you have the case when then. Here it's an if. So here we can say if, for example, the line total is smaller than 100, or equals the quantity equals 1. You can use an or in between, or you can use an and. In this case, I'm using an and, so it's between 100 and 500. Here what you can see, that's a little bit strange. It's not an else if, but an elif. So that's typical in Python. It's shorter, so that's what they prefer. And behind here you can see a colon. So if colon, and then you can specify what you want to do. And the important thing about Python is it's all about indentation. So you need to enter a tab here. So if you don't do the tab, then it doesn't know what you're doing. Let me show you. So here you have the same code. Let's check it, is it working? So the line total is 602. So this is considered a large order. So it's between 500 and 1000. So that's okay. What happens if I don't indent like this? You see everything becomes red. So I need to indent it. So that's important. And if I do it like this, that's okay. But the idea is that everything that's indented, so if you want to do like two things in this if construction, then you can type them in here. So this is the if, then we have the elif with the colon, elif with the colon, and the last thing is the else, and then also a colon, and then the lines. If you're working with arrays, they call a list here in Python. I can assign a list with square brackets, and then you can put elements in the list. And then here I can say, okay, for example, I want the first element. You can use the index 0 or index 1 as a second element, but you can also do index -1. So that's interesting. So then you get mango. What will happen if you do from 2 till 5? You get index 2, 3, and 4. The same like we saw with the string. What does this do? This do. Column 3 means everything before 3. So 0, 1, 2. And the same here from 4 up. So 4, 5, 6. If you want to add something, you can use the insert to insert at exactly that index, or append to append it at the end. And if you want to remove something, you can use the pop. Loops, what if you have like a list and you want to loop through it? Maybe you have a list of tables or SQL Server databases that you want to get data from. Then the loop can be very interesting. It's really easy. You can use a for item in my list, and then item contains the item apple, banana, cherry in this case. Or you can do it more traditionally with indexer, that's 0, 1, 2, 3, and so forth. Or you can use a while loop, but let's stick with the for. And then last but not least, we have the dictionary expressions. This is like JSON. If you connect to REST API, you get JSON back. That's the same like a dictionary. It's basically an object. And here you define the dictionary with all the properties that you want to assign to it. And then, for example, I can create a list of dictionaries. Then it's really like a REST API where you get JSON back. And with a for, you can also loop through it and get all the car objects one by one. And then here you can get something. You cannot use the dot operator. You cannot say car dot brand. So you need to have use the square brackets. Okay, let's take a look at modular programming. For example, how to define functions. Maybe you have some code that you want to reuse. Then it's really handy to define a function with the def. You can define it, you give it a name, and then we have some input parameters. It's optional to have type hints. It's good to do that because then in the intelligence you can see what is expected there, but you can also leave it out. So this is string, and the output can be string, and here you can do something with it. And then you can call the function, just call the function name with the input parameters, and so print something. And you can also use name parameters, so that makes the code more readable. Okay, first name equals fname, last name is last name. And these are the parameter names. Modules, that's very important. How can you import a module? You can say import datetime, and then you can use it. You can also specify an alias, like from now on data time is called dt, and then you can use dt.date. That's a very convenient way to import everything from the module. But you can also specify like which things do you really want to import. I only need the date, datetime, and time delta, so I'm only going to import these. So it's up to you which syntax that you want to use. And if you want to have packages, you need to install them. And for that you use the Python package manager pip. Pip is connected to a website, PyPy, And there you can all find a lot of packages that you can use. You can also look for packages there. And then you can use pip to install a specific package with a specific version. If you want to see which packages are already installed into my Anaconda installation, for example, you can execute pip and then list. And what I opened up here is a notebook. So now we're also going to take a look at the Jupyter Notebooks. So this is not a Py file, but the IPython notebook file. And a notebook has cells, and each cell you can run separately, so it's very easy to debug. In this case, for example, I want to use pip list. Why do I add an exclamation mark? Because I'm not running in a command prompt. Normally you use a command prompt to execute pip, like an Anaconda prompt, but I can also do it here. Execute this cell, and then it's going to show me a list of all the packages installed in my installation. What is a Jupyter Notebook? Jupyter Notebook is an IPython notebook file. It's an evolution of IPython. They wanted to create something to code Python in the cloud, in a browser. So that's why they call it IPython. And Jupyter is named after Galileo's notebooks. And the term Jupyter consists of three things: Julia, Python, R. And these are the three main languages are being used inside Jupyter Notebooks. But there are nowadays more languages than these three. Besides cells with code that can be Python, Julia, or R, or SQL, there's also something called Markdown. That's like a simplified HTML. And you can use these codes. Like 1 hash is a big header, 2 hashes a small header, 3 hashes a subheader. You can make things bold or italic or strike through, or you can make like items, get like a bullet list or a numbered list. Or you can add hyperlinks or images, and you can also add a code block. Okay, now let's make it a little bit more interesting and start really using Python to do things data engineering related. One of the first libraries we're going to use is Pandas. Pandas is based upon NumPy. That's another library that contains a lot of C code to make matrix operations and linear algebra very fast. So yes, you can work with lists, but it's relatively slow. If you work with lots of data, you will want to manipulate it, then NumPy is a very good library. As you can see here, it's up to 50 times faster than traditional list. And it's based upon numpy.array. And main part because of the fastness is the vectorized operations. What does this mean? What you can do is you can basically take two arrays, like array 1 and array 2, and you can just multiply these two arrays. And what will it do? It will multiply all these numbers at the same time into a third array. So if you have a scalar operation, it's very time consuming. It can do it like this. For example, if I add two arrays, array 1 and array 2, it can do it one by one. 1 plus 2 is 3, 2 plus 1 is 3, and so forth. That's 5 operations. If it's vectorized, then it's just one operation. So it's 5 times as fast. This is fully optimized for the processor, so that the processor has some tricks to do this at the same time, like parallel. Of course, you cannot do it with 50 billion rows at the same time. The processor has some cache for that, but it's way faster than do it one by one. So that's a neat trick, and that's what NumPy offers. So you can just add two arrays and all the values inside will be added up. Pandas is built on top of that. Pandas uses series, and these are one-dimensional NumPy arrays, and that's basically a column. So each column contains a series of values. And the whole thing, the rows and the columns together, that's what I call a data frame, a Pandas data frame. Let's look at some basics. First thing you need to do is, of course, install the package Pandas. And then you can import it and give it an alias. And then here I can define some series. And if you want to define a whole data frame, then it's basically a dictionary with keys, and these keys contain series. That's what a data frame is. And then with this data frame, I can look at the typing. So for example, here I have an order date and a ship date. We know it contains dates, but the Pandas data frame doesn't know yet. So if we look at the info, we'll see it has a different type. And you can use the .as type to cast it to a specific type. And then you can use these different types. Let's look at it from a code perspective. So here we have this data frame. I can just execute the cell, and then here we can see that this order date, ship date is just an object. That's not good enough. So that's why I cast it with the as type, and if I do then again dataframe.info, you get the correct type info. So that's what we want. Let's see how we can do some calculations. If you want one specific column, you can just take it with the indexer, like a dictionary. Basically, it's a dictionary, so you can use it like a dictionary. And you can also use vectorized operations because it's built on top of NumPy. So if you want to multiply quantity times price, you can just assign it to a new series line total. And you can also give it then here a new name. So this is how you create a calculated column, line total. What if you want to do things with it? For example, I want to get round it upwards, like with the ceil function. This doesn't work. So if I execute it, you get an error. Only works for scalar values. So what it says is this function is not vectorized, so it doesn't know how to vectorize it. It can only do it one by one. And what I do here is I want to try to do it on all the values at the same time, because this is not one value, this is the whole series of values. And for that, NumPy has vectorized operations. So instead of using mat.ceil, you use numpy.ceil. And this is vectorized. And then it works. So that's what you need to do. So let's comment out this one. And this is the correct one. The same with dates. If you want to get like the year from the order date, you cannot do it like this. So if you would say order date dot year, it doesn't work because it also only works for scalar value. So again, here we need to do it differently, and that's where we can use the accessors, the date accessor. And you can say datetime.year, and it's going to do it for all the values. It's going to give you the year. And if you want to do some calculations, for example, ship date minus order date, I want to get the lead time, you subtract and then .dt .days. The same here with string operations. If you want to have like the lowercase, you can say .str, .lower. If you want, for example, the first character as upper, then you first need to get from all these values the first character, and then use the string accessor again, and then have the uppercase. And then it's fully vectorized. So it's a different way of working with it, but it still works. And if I display the data frame, then you can see it working. So we have the lowercase for the first name, we have the first letter uppercase, and we have the year of the date, and the line total is rounded upwards. Okay, let's go back to the slides. How can we work with files? First, we're going to look at local files, and then we're going to go to Fabric, because that's where you're all been looking for, I guess. Of course, you can also work with local files. You have some CSV files, you want to import them. Then you can use pandas.read_csv. You can specify the path, you specify the separator. And then maybe you want to parse some things. You want to parse some numeric data or some datetime data. With datetime, they have a convenient format. So in this case, for example, it's month, day, year. You cannot see it, but it's month, day, year, and then it will parse it correctly. One thing to look out for, if, for example, you have a comma as a 1000 separator, like we have in the Netherlands, that's a little tricky. It cannot parse it. So I need to first replace it with nothing. And then I can just import it. Calculated colors we already seen. Let's take a look at Azure. So now we're going to take a look at Fabric and Azure Data Lake Storage Gen 2. Blob storage basically. So if you have your data in a data lake, maybe you already have a data lake in Azure, then you can just connect to that via ABFSS. That's an Azure Blob file system that you can use from Python. And how does it work? You need to specify a storage account, an account name and the key. And you need to have like a URL, the protocol with the container and the path. And then you can just use Pandas to read the CSV file and bring it in. I don't want to do that. I want to use one lake and Fabric. because that's behind the scenes also Azure Data Lake Storage Gen 2, but we don't need the storage account. Let's take the first one. Okay, so how does it work? So here I'm in an app.powerbi.com, basically in Fabric. And what I created here in Fabric, I created a lakehouse. What a lakehouse means, I'll explain in the next module, but for now I have a lakehouse with files. And later on we get tables. And these files, here I also have a CSV file in the file section just in the root. If you click on files here, you can see all the files that are there. And for example, here I have an orders.csv. If you want to import it with Pandas, you can specify the file URL absolutely or relatively. It's really easy. If you go to the file, click on the three dots, and here you can copy the ABFS part, the full part, or you can copy the relative part. Let's take this one, just paste it here. You can see this is the relative part you can use. So it's specifying the lakehouse, the default lakehouse in this case to which we are connected, and then the files folder, and then the file itself. What you also can do is import Excel sheets. Pandas works very well with Excel. You need a different package, open PyXL, and then you can specify the URL. It only works with the absolute one lake part, I noticed. So the relative one doesn't work. But yeah, that's not really a problem. You can read Excel and then you can play around with it. Also interesting can be to connect to SharePoint. That's something that maybe is sometimes difficult if you're using pipelines or Azure Data Factory. They're really not suitable to connecting to SharePoint like Power Query can. But with Python it's not really a problem. If you have the correct API library, you can connect to it. You can authenticate with the username, for example. Of course, you should store it somewhere secure, not like this. And then here I can specify the URL and the path, and then you're in. You basically get the Excel sheet into a data frame, and then you can do whatever you want with it. What kind of things can you do with a data frame? We've seen you can calculate things with the vectorized operations, or the date accessor, or the string accessor. You can also select columns, of course. It's a little funny. You have the square bracket, and inside we have a list. So you specify a list of columns that you want to select. You can also filter. Then in this square brackets, you can specify a predicate. And you can also sort by using sort values. You can also use the group by function to group based on year and month in this case, and use all kind of aggregation functions like sum, mean, max, median, and so forth. And of course, you can also rename the columns afterwards. And you can also drop some columns if you like. And then you can print the end result and you get it like this. One thing to notice, if you group, then you have different rows. So you need to reset the index, because all these rows in the series, they have an index number. So it's important to re-index them. Okay, for the rest, there are a lot of things you can do with Pandas. We're not going to cover all of them, and because of the time, you can merge, you can unpivot, you can pivot. Merging is like a left and right table with a join type, left, right, outer, inner, just like SQL. There are a lot of options here. Now I want to look at Parquet files, very popular format. Basically the same format that also Power BI uses in the Vertipark engine. It's a columnar storage, so instead of storing it per row, it's stored per column. So it's easier to compress the data using some techniques like dictionary encoding that is going to replace a text with a number. And it's using run length encoding, so everything is put in a certain order, and it doesn't have to save all these numbers. So instead of saving 1, 1, 1, it's going to just say 3 ones, and then 1, 2, and then 2 ones. And then 4 3s, and that can make it short, more compact. And the nice thing about Parquet files that it has as a benefit over CSVs, it has metadata, so it knows exactly which column has which type, just like Excel basically, but it's a way more better format than Excel. You can really easily work with Parquet files in Pandas. You can just specify read Parquet, you read it in, and then you don't need to worry too much about the typing, because the typing is already done for you, and you can just focus on creating new columns Also here you have the data accessor. That's all the same like with CSVs. You can also work with folders. What if you want to have a whole folder of Parquet files? Then we have some extra tooling, the MS Spark Utils. That is a tool that Microsoft built inside Fabric to work with the file system, because that can sometimes be a little bit tricky. And with these tools, it's really easy to get like a listing of a specific folder path. Then you get a list of files, you can loop through the files, read the Parquet in the data frame, and then append the data frame to a list. So you have a list of data frames, and then you can use pandas.concat and take all the data frames in the list and put them in one big data frame, for example. So that's a way to do that. You will see in Spark it's easier. This is a little bit messy code maybe. You can also save to OneLake. If you want to upload a file, you can use the to Parquet or to CSV, and you can put files in the file section of OneLake. Okay, let's take a look at this Lakehouse and PySpark. What is a lakehouse? We used to have data warehouses for a very, very long time, and they work pretty good for traditional reporting. But what if you have a lot of data? Then it can become very expensive, it scales out very poorly, and it's not very suitable for data science and machine learning, because these people need raw data lots of times, especially if you have big data. This is not the best solution then. Then came along the data lake, was built on top of Azure Data Lake Storage Gen 2, blob storage with folders basically. That works pretty good for the data scientist, but then we have more complex ETL because we have a lot of data redundancy. So that's also not optimal. And a lot of times if you query on top of the data lake, the performance is rather poor. So what was introduced later by Databricks, it's called the Lakehouse, based on Delta Lake technology. And because this is open sourced, Microsoft could also use it in Fabric. And that's what I did. What is Microsoft Fabric? It's a SQL endpoint. The SQL endpoint is just a SQL endpoint. You connect to it from any tool that knows SQL, like Power BI and Excel. We have the Spark engine for the machine learning and data science and running the Python and notebooks, and also hosting some SQL. And we have also the Spark engine with the Delta Lake technology to save the data in the Delta format. And the Delta format is Parquet files plus a transaction log. So you can also you can also update the data, insert, update, delete, use even merge statements on top of the data. And it is fully transactional using the asset transactions. And there's a management layer for that. That's what the Delta Lake does for you. It gives you like a new kind of database. So that can be really interesting. And you have just one place to put all the data. And the data itself is stored in these Parquet files inside OneLake. It's like a OneDrive for BI, for databases. It's really easy to put data in the OneLake. But underneath it's still Azure Data Lake Storage Gen 2. So a lot of tools that use that connection, they can still use also OneLake. Let's take a look at Fabric. We're going to focus on the data engineering part. It's using serverless compute from Apache Spark, and basically you can save the data in any format you want. A more traditional warehouse, connecting to it from SQL Server Management Studio, or the Lakehouse, you connect to that via Python, or a data set in Power BI. And it's all saved in the Delta Parquet format. What is Spark? Spark is introduced in 2009 by Berkeley University. It's open sourced and is now donated to the Apache Software Foundation. And the keyword is distributed. It's distributed across a lot of clusters, and with that you can scale out to handle big data. It's a lot faster than Hadoop, the predecessor, and it has a nice rich API with a lot of languages. You can choose Python, Java, Scala, R. Scala is like a Java dialect. And we are going to focus on Python. So here we see Python as one of the languages, but you can also use SQL. That's rather interesting. That's what I call the Spark SQL. So a lot of times you don't even need to use Python. You can just use SQL, like a select or insert or update, delete, merge. They're all available inside Spark SQL. But for now we're going to focus on the data frames in combination with PySpark. Here we can see a data frame can define it in a structure with some types, and here I can create a data frame and put in some dummy data, just to show you some things. So here I have some columns like ID, date, and a name. If you want to do something with these columns, like for example, I want to multiply the quantity times the price, you can also use factorized operations here, just like we saw in Pandas. That makes it very fast. And if you want to do some functions, they're all here in the functions library, like ceiling, rounding, taking the year of a date, or do a dative, or take the lowercase or uppercase, or do a substring. But sometimes, if you want to do more complicated things, like for example, I want to get the first name, so everything before the space I want to get, I could create this expression, but it will fail because it's too complicated. It cannot factorize it basically. So what you can do then is, here is a dot expression, and here you can basically put a SQL expression in. It will not be as fast as factorized operations, but it will still work perfectly fine. And that gives you a lot of flexibility. And then I can show the data frame, and it's going to execute everything. All these operations, they will be merged together into one execution plan, just like SQL Server, and then it will execute the execution plan distributed across a lot of nodes. So that's what will happen. How can you work with files? Let's move over to Fabric itself. It's more interesting than the slides. So here I have the workspace. So Fabric works with workspaces, and inside the workspace we can create the notebooks for the Python code, and we have also a Lakehouse. So I'm going to open up this Lakehouse. And inside the Lakehouse we can find two things. We can find files and tables. These are the files. If you click here on files, I can see which are in the root folder, and I also have some subfolders with also some files. And we have tables, and these are the Delta tables or the Parquet tables. We're gonna create them in a minute. These files, how do I can bring these files in? You can do it using Python notebooks, or you can use pipelines, or data flows Gen 2, or you can just go to the browser, the Windows Explorer, and here I see the same Lakehouse, and here we got the files, and I can just drag files in, can just copy paste them. It's just like working with OneDrive. You put the files in, it will be synced, and you can use them. So that's really easy. So let's see how we can open a file. For example, I want to work with a CSV file. What can we do? I want to get the order CSV file. I go to files. Here I see the file. I click on the three dots, and there I can copy the absolute part or the relative part. Let's take this one, and then you can get a whole long part. So this is the whole part to the file. What you see here, the first part is the workspace. This is the same GUID that you'll find in the URL 4291. So that's the workspace GUID, and then here we find the GUID of the Lakehouse. And with that, then you get files and orders. But you don't need this long URL, it's rather long. You can also take this one, the file API part, and then you get the short version. How does it work? You can even leave that one out. You can also take this one, relative part for Spark. This is the only one that's necessary. How does it know where to look? This notebook is connected to a Lakehouse, so it's going to look in that specific Lakehouse. And with that, it can find this orders.csv file. You can also load a whole folder. In Pandas, that was a little tricky. Here it's really easy. You just specify a .csv, and it will get all the files and load them into one big data frame. Spark.read.load, you specify the part, which kind of format it is, separator, and then it's going to load the data. How to parse date columns, you can specify to date and then the format. And here I can create some calculated columns. If you want to import Parquet files, basically the same. The only difference is you say spark.read options, and then here you can say the format is Parquet. You can also see the simple version. So here it's going to load all the Parquet files in this folder structure 1, 2, 3, 4 levels deep, and then it's going to take the files. Do you want it recursive to take the files on all the levels? You can set this option, recursive file lookup. You can also import Excel sheets, basically also with this library. If you want to work with Excel sheets, PySpark doesn't natively work with Excel sheets, so we can do a trick. We can read the Excel sheet using Pandas, and then we can create a data frame from the Pandas data frame. Pandas has more broader scope. You can handle more files than PySpark, so this is like a trick to still get to the file. What can you more do with PySpark? You can also get the year and the month like we saw. You can also do filtering using the filter function order where. Where is more like the SQL version. You can type in here SQL, or you can do it the Pandas way. You can also group on columns, you can aggregate, you can create new columns, you can select columns which you want to see, you can sort rows. And there are a lot more transformations you can do, like unpivot the data or join the data. But let's move on. Let's take a look at how to insert data into the Lakehouse, whether it be files or tables. Let's move over to Fabric. Here I have a folder, orders.csv. I want to take these 3 files and put them in one Parquet file or in one big CSV file. Here I'm going to load the files, order.csv, everything with .csv. And then what I can do is I can write the data frame in the mode override or append. Override means it's going to throw away the file if it exists and override it, and append means that you add extra data to it. And you can choose the format CSV or Parquet, and then you will have the save method to save it in the files. And in this case I want to choose the raw folder, and in this raw folder I'm going to put the files. You see it's empty now, so now I'm going to run the script, and now it's going to create these 2 files. And now if I go to the raw folder, then you can see there they are. Nice. But another thing you can do is you can also create tables, and that's even more interesting. We have the same mode, append or override. I'm going to specify format Parquet, save as table, orders Parquet, and delta, save as table, orders delta. If I execute this code, okay, now it succeeded. I'm going to move over to the table section. If I open it up, nothing appears. If I click here to refresh, then we see 2 tables, orders Parquet and orders delta. If I open it up, and you can see a different symbol. This is the delta table and this is the Parquet table. What's the difference? The delta table actually supports transactions, and you can even update the table or do an insert or delete, which is not possible with the Parquet. It's write only. So what can we do with these tables? These are basically just tables, just like any tables in the database, and you can create queries on top of it. So I can say select from orders Parquet, group by year, order by year, and I want to select the year of the order date and summarize the line total. Just like you would in the Management Studio with T-SQL. This is not T-SQL, this is Spark SQL. But it's basically the same. We have the same kind of functions. It's ANSI SQL. A lot of SQL is the same like in SQL Server. So this is really interesting. And if I have multiple tables, I can also do joins to the tables. All the SQL that I'm used to, I can execute from here, specifying the language SQL. Another way to execute SQL is from Python. So maybe you want to have the results in a data frame. That's also possible, of course. Here I declare a variable with the 3 double quotes. Here is my SQL. And then spark.sql, I'm going to execute the SQL and it's going to put it in a data frame. And then I can do whatever I want with it. I can save that in a CSV file or a Parquet file or the other table, whatever you want. Another thing to mention, it's the medallion architecture. That's something that you can do. You don't have to do this, but a lot of companies do this. They have like a few layers like bronze, silver, gold. Bronze is normally where the files will land, the raw files. And then you can put them in delta tables, like I showed you. That's like the silver layer. And then you can create like a new layer, the gold layer, where you create fact and dimension tables, like the star schemas. And that's what you're going to import into Power BI, for example. The last thing I want to show you is how you update the data in the delta tables. You can use just regular SQL for that. Insert, update, delete, and also the merge statement are fully supported. For example, in this case, I have some products in the inventory table. I want to update them based on some updated data that's coming in. I can use a merge statement, comparing the inventory with the updated inventory, matching based on the product ID, and if there's a match, I'm going to update. And if there's not a match, then it's not existing, and then you can do an insert, for example. Really easy to do. With that, we have come to the end of this presentation. There was a lot more I want to share with you, but we only have so limited time. You can find all the demo code and all the slides in this URL. And if you have any questions, feel free to reach out to me via email or LinkedIn. Thank you.